Hello, this is Mr. Agbamu Idonobrene. You are welcome to Wednesday's lesson, 4th of March 2026. This lesson is on angles between lines. So today we want to continue from where we stopped yesterday. Yesterday, I wanted us to do a practical demonstration of intersecting lines. When two lines intersect, what are the properties of the angles between them? Those were the things I wanted us to do yesterday. That is why I said use your protractor to measure those angles. Check the ones that are equal, add them and see the one that will give a particular number like 180 or 360. So most of us did the work yesterday. We submitted the classwork today and the assignment. So I'll mark everything by the end of today and return the note. Anyone that can't complete the marking today, tomorrow by God's grace, I'll complete all. Now let's look at what we are going to do today. Today is the theory part of the topic, angles between lines. So what is the theory part doing now? We want to identify the angles now formed between intersecting lines. If you identify them, know the ones that will sum up to get 180, know the ones that will be equal, which are vertically opposite angles, then know the ones you will sum up to give you 360 degrees. Now let's go to the first theorem. So the first theorem or the first properties of intersecting angles we want to learn is angles on a straight line, which is equals to 180 degrees. So you can see a straight line ACB. So this is a straight line. So when you check the angles on this straight line, if you place your protractor on this straight line, you already know that it will give you 180 degrees. Just like what we did in the demonstration of yesterday. Let me open yesterday's work again. Let me go back. Okay. Okay, so this was yesterday's work. So if you observe very well yesterday, you will see that all the straight lines where I placed the protractor yesterday, you will see that every angle on the straight line, if you start from 0 on this side, it will go and end up 180 degrees. So this is angles on the straight line. Even the next example, if you look at this, all these straight lines from A, O, B, if you place the protractor on the straight line like this, if you place it and you check, you will see that from A through to O down to B, you see that it's 180. The protractor measures the angle, it will give you 180 degrees. So this is where the first theorem is coming from. That is our first theorem, this property. That's what it's saying that when you have a straight line like this ACB, any angle on the straight line must give you 180. So if a line now come and cross the straight line like this CD line, the CD line now cross the straight line and divide it into two parts. That means the angle ACB, which is A to C to B, if you add it to the second part of it, which is B to C to D, that's what I mean by angle ACB plus angle CBCD. If you add it to give you 180 degrees. So anyhow the straight line is, it must give you 180 degrees. So this is the first theorem I want us to learn today. Angles on a straight line, 180 degrees. So the next theorem I want us to learn is this. Now this theorem is on vertically opposite angles. We also did it yesterday. Let me still go back to the smart notebook. Okay, this is the smart notebook. So you look at the smart notebook, these are vertically opposite angles. I demonstrated this yesterday. You see that this side is 116. I measured it yesterday. This is yesterday's note I gave us in the lesson I sent. So this 116 equal to 116. When you place your protractor, now I demonstrated this yesterday, and you measure from 0 to this side, you see it will give us 116. If you turn the protractor to the other side and place the 0 here and measure the 0 like this, you see you still get 116 as well. So this was the demonstration I did yesterday. So this is okay. Let's leave this one for the last property. So let me go back to our notes. Okay, now let's go back to our note. Now you can see that because the opposite angles, like vertically opposite angles are equal, you see the way I label it. AOC, where is A? This is AOC. You can see the AOC is equals to D. This is DOB. Just follow the label of the letters. Follow the label now. This DOB. That is this angle. Then you must put the symbol of angle, telling you that this is an angle. It's not just a letter. That's why you need these symbols. Then look at the other AOD. This is A, follow to O, follow to D. So the angle on this side, which is this one, the angle on this side here must equal the angle on this side because they are vertically opposite. Take note of that. That's what I mean by AOD equals to BOC. AOD equals to BOC. So take note of this second property. Very, very important. Now let's go to the last property. This is angle at a point. So angle at a point is equals to 360 degrees. So what do we mean by angle at a point? We're talking about all the angles surrounding the plane shape, surrounding the intersecting lines, all the angles surrounding the intersecting lines. So you can see the two lines AOB and COD, they intersect at this center point O. So this straight line, if you check all the angles, this is AOC, AOC. Let me be labeling them. This is AOC. If you measure AOC, you add it to AOD. This is AOD. This side is AOD. See AOD. This is AOD. If you add it again to B, this is B to O to C is down. BOC is down. This is BOC. If you add this one again to the last one, which is DOB, which is this side, DOB. If you add these four angles, because they are all surrounding a point, it must give us 360 degrees. So by knowing this theorem, you are okay and you are good to go. So that is all we are doing in today's lesson. If you understand these three properties, angles at a point gives us 360 degrees. Then angle on a straight line gives us 180. Then vertically opposite angles are equal. So this was yesterday's note, what I demonstrated yesterday. You see the two lines, A to B, C to D. I measure all the angles around it, which is angle at a point. You see, it forms a circle. And by the time you add all these angles, see where I added all of them, it gave us 360 degrees. So this was the thing we did yesterday, the lesson of yesterday, and I want us to learn the properties and use it to solve questions. Now that we have known the three properties, angle at a point, vertically opposite angle, and angles on a straight line. Now let's use this to solve example. Now with the theory now, you should be able to solve simple example of this kind and any other type you will see. So today's first example is this. We said in the diagram below, AOB, see AOB, always follow the label and follow it according to the line. It will help you to know what you are doing. So AOB, you can see that it's a straight line. Then COD, you see, they are all straight lines. And they meet at where? At point O. You see, this is center O. This is where they meet. Now, if these two straight lines meet at O, there's an angle on this corner, and this angle is BOD. They even said it here, angle BOD is 53. BOD is 53. Now that BOD is 53, what are we looking for? They say we should find AOC. Where is AOC now? This is AOC. Let me get my pen. Now, AOC is this side. You can see from A here, trace down to O, then trace down to C. So that is this angle. And if you observe, it's facing 53. So this is a vertically opposite angle. So without wasting time, just go straight to your solution. You can number it number 1, put it in bracket. You can say number 1, angle, put your symbol for angle. Angle AOC, angle AOC, which is the first solution, is equals to 53. There is nothing to calculate here. Let me erase it, it's too big. There's nothing to calculate. Your answer is just 53. And in case you want to know why it's 53, why is this angle 53? You already know why it's 53 degrees. It's 53 because it's facing this, it's vertically opposite to AOC. So just write, in case you are writing exam and your marker want to know why, just put it in a bracket. You can just write vertically opposite angles. So that is that. Vertically opposite. You can abbreviate it, they will understand. You can just say OPP or you put it in full. So that is that. So vertically opposite angle. Or you can use the symbol of angles and put S. Anyone is accepted. So close the bracket. So these are vertically opposite angles. If you see this symbol and you put S, it also means angles. Or if you just see only this symbol, it means angle. So these two angles are vertically opposite. That is the answer for number 1, that is AOC. Let's look at the next one the question say we should do, which is AOD. Now, if you observe AOD, let's trace it. This is AOD. That is this top one, this top angle. This top angle is the AOD. Let me use double line to differentiate it from this side. Now, this top AOD, how do I get it? You see, AOB is a straight line. So what do we say about angle on a straight line? We say angle on a straight line is equals to 180 degrees. So AOB is a straight line. So 53 is already part of it. So AOD is on the other part. So why not just say angle? Put your symbol of angle. AOD, AOD. Just put it now. Add it to 53 because they are all on that straight line. Angle AOD plus 53 equals to 180 degrees. So anybody that sees this will know the reason. The reason is they are on a straight line. If you wish to tell us the reason, you can put it in bracket beside this thing. Just write straight. You can just write straight line. You can just say straight line. You can abbreviate it like this, straight line. The examiner will understand. Okay, so close the bracket. So these are straight lines. Now, if this is a straight line angle, which is 53 degrees, what do we do next? You know your simple equation now. You see why we say equation is the basis of mathematics. Now, how do I get AOD? I'll collect like terms. And how do we collect like terms? We said positive 53 will cross to this side. It will now become negative on the other side, which will now become 180 now minus 53. 180 minus 53. And that will give us our final result of what? So 180 minus 53. Can we check it very fast? So 180 minus 53 is 127. So that is the AOD. So this is the first example in today's lesson. So this side now will be 127. In case you want to write it in your book, then this side will still be 53. So take note of that. So that is the solution to this example. So that is the solution to this example. So let's go to example 2, and that is all for today's lesson. Now this is example 2. You see in example 2, let's read the instruction before we start. It says in the diagram below, AOB, this is AOB, you can see it's on a straight line. So even without telling you, you can see that it's straight. So AOB is a straight line. Then COD, see COD, see this is another straight line. COD, they are all straight lines and they meet at where? They meet at O. Take note, there's another line that comes from O to E. It did not go across, it just comes from O and stop E here. So that line have another angle called 77. So this OE is not a straight line to OD. So you cannot do 62 plus 77 equals to 180. So then we'll go and make that mistake. So 62 plus 77 is not 180 degrees because O to E and O to D, if you follow the lines, but it's not a straight line. The only straight line we have here is DOC. DOC. This is the only straight line we have. So how do we solve this one now? And what did they say we should do now? Okay, they say calculate the other angles. Okay, we have about 3 other angles. This is 1, 2, 3. Let me put my pen. So we have 3 angles. This is 1. We have another one here. 2. Let me make double line here. 2. Then we have another one here. Let me make this one triple line. 2, 3. So these are the other angles they want us to find. 1, 2, 3. So let's start. Remember the first one that will be easy for us. This one will be easy for us because it's facing 62 directly. Remember, they say CD, see COD and AOB, they are straight lines. So the first one I will do, which will be the quickest one for me now, is AOC. So angle AOC now is facing 62. AOC, angle AOC will be equals to 62. That is that. So we don't need to calculate anything. And why? You already know the reason, because if COD is a straight line, then AOB is a straight line. 62 is facing this side, so this is vertically opposite angle. So you can put your reason in bracket. You can just spell it in. You can abbreviate it if you don't want to write it full, but the teacher will understand. So this is vertically opposite. So that is the reason why this 62 is equal to AOC. So vertically opposite angles. So we are through with AOC. See it, AOC. Now let's find another one we can get easily. Now that I know my AOC now, I can get this side now. I can get AOD, because AOD and 62, they are lying on a straight line. See the straight line, AOB. So they are lying on this straight line. So I'll just say angle A now. Angle AOD. Angle AOD. If I add it to 62, angle AOD plus 62. So this one will be what? AOD plus 62 will give me what? Give me 180. And you know the reason, because it's on a straight line. So 62 and AOD, they are on a straight line. Take note of that. Now that they are on a straight line, collect your like terms. So AOD will be what now? AOD now be equals to 62. When it crosses over, it becomes negative. So it now become 180 minus 62. So when I minus 180 minus 62, what will I get? Let's see. So this one will give us so the answer will be 118. 118. Take note of this. So that is the second angle. Then the third angle, which is this one, I use 3 dashes to label, and that is COE. You see it, COE. How do I get COE? Let me do it on this corner. That is number 3. So how do I get COE? If I want to get COE, I can even use angle at a point, because now every angle has been known. I've known this side, I've known this side, you see. So this is the only one I don't know. I can add everything equal to 360 degrees. Or I can use angle on a straight line. Since I know 62, I know 77, I can now add this one to it. You understand? Equal to 180. Any one I choose is what I will use. But let me use angle at a point to solve it. Since I already know these two now, I know my AOD and I know my AOC. So let's use that one to solve it. So if I use angle at a point, let me start with 62. So 62 plus 77. Understand? I'm adding all the angles around, and it will be equal to 360 degrees. So 62 plus 77 plus AOC. What is AOC? AOC is also 62 plus 62. Don't forget, I've calculated here, sorry, this is AOC. I've calculated here to be 62. I've calculated here to be what? Now to be 118. So 118. If you observe, it's not equal to 77, because this OE line is not a straight line. So there's no vertically opposite. 77 is not a vertically opposite angle. So it can never be equal to this angle. So take note of that. So 62 again, understand, 62 plus 77 plus 62 plus 118 plus 118, then plus the last angle, which is the COE, plus the angle. Don't forget to always put your symbol of angle, plus COE. Very, very important. Plus COE. By the time you add the three of them now, sorry, by the time you add all the angles 1, 2, 3, 4, 5, your answer will be what? It will be equals to 360 degrees. So very, very important. So this is angle at the point. If somebody asks why is it equal 360, tell him it's angles. You can put the symbol of angle. Just say angles at, just say angle at a point. So whoever sees it will understand. They are all standing at this point. All on this point. This is angle at a point. So that is that. So now that you have done it, you can now finish your solution. Add all your like terms, which is 62 plus 77 plus 62 plus 118. So let me add it and let's see the result. So 62 plus 77, that will give me 139. Then plus 62 again, so give me 202. Then plus 118, which is 390. So just write next step 319. So 319 plus the COE you are looking for now, which is this angle you are looking for, angle COE. So it will be equals to what now? Equals to 360 degrees. Now, to end this work now, collect like 10. 319 will cross over. So when 319 cross over, it will now be COE equals to your 360 minus 319. So let's write it down. 360 minus 319. So take note of this. Do it on your paper and check. Make sure your answers are correct. So if I minus it very well now, let me see what 360 minus 319, it will give me 41. So this angle is 41. So angle COE, that is this angle on this side, is 41 degrees. Take note of that. So this is the solution to the remaining angle that they say we should find. Calculate the other angles: 118, 62, and 41. So that is all for today. So with these two examples, we are confidently now explain the three properties we just mentioned today: angles at a point, vertically opposite angles, then angles on the straight lines. So with this, we are through with today's lesson. We shall do more examples tomorrow. Tomorrow we are going to continue with this topic. When we do more examples tomorrow, then on Friday, if we have time to learn, because of cultural day, we may not learn. Or on Monday, we continue with the topic, and that will be the last part of the topic. Then that is going to be sum of angles in the triangle and parallel lines. Those are the last part of the topic. So Monday or by Tuesday, by God's grace, we should be through with this terms work. So that is all for today's lesson. Well, after studying this example, you can do this classwork and assignment. Though we are going to continue from here tomorrow. We are going to continue from here tomorrow. But if you can do all of them, do all of them, because I just put 578 here, 578. This is from your textbook. I just screenshot it and label it here, 578. You can do 6. Just do all of these are the examples we shall do for the topic. Then this is 2 and 4. You can do it as well. It's just a practice question. And tomorrow I'll bring more examples. We'll do more examples in class, more classwork, and that is all for the lesson. Okay, before we end the lesson, I have an applet I want to show us. Let me show you the applet, and I will send the link also so that you can use it to understand this topic very, very well. So you can see the applet. This applet is just an applet that talks about vertically opposite angles are equal. You can see this is 130 degrees. This is 130 degrees. They are facing each other. They are vertically equal. So if I turn it to any extent, you will see that they are still facing each other. So when two lines crosses each other, the two opposite angles are equal. We call them vertically opposite angles. You can see it's a vertical angle. If I click on 2, see this is another vertical angle. They are called vertical angles because they are facing each other directly. But if I want to do linear angle, which is angle on a straight line, something like this. See, this is angle on a straight line. See, to give us 180. So by the time you sum this side and this side together, to give us 180 degrees. You can play around the applet, see the way I'm turning it, and with that way you understand it better. So this is all. I will send this link to you so that you can still use it and play around to understand this topic very well. That is all for today's lesson.